So before I begin, let me introduce myself first. My name is Bikram, working in IBM Labs as advisory software engineer, working in a product called Instana, which is also an observability product, and been into this domain for around last 4 years now, having around 30 plus years of experience. And today on the high level, I will be covering this particular topics. We'll be starting with OpenTelemetry, its brief history and highlights. Then we'll see what are the different telemetry data that OpenTelemetry has, followed by its core components, its architecture. Then we'll try to understand what magic basically the Observability Backend does. And then we'll wrap up the session with a small demo. So first thing is, what do we mean by the OpenTelemetry? So OpenTelemetry is nothing but it's an observability framework, which basically helps you to understand your system in much more detail or deeper way. At its core, it aims to deliver a high quality, ubiquitous and portable telemetry. Now let's try to understand what do we mean by these three terms. So high quality basically refers to the precise data and the meaningful data, whereas ubiquitous basically refers to the wide variety of languages which OpenTelemetry supports. And last, the portable means once you collect the data from your underlying system or the application, you can port it to any of the observability backend basically. And together basically it lays the foundation of effective observability. Now let's quickly go through the history of it. It started long back, around 2010, when Google published a paper called Dapper on the distributed tracing. Followed by that, inspired by that, basically Twitter built Zipkin, Uber built Jaeger, and in 2016 Open Tracing came, which basically focusing on the tracing part of the application. And 2018, again Google published one more, open source one more product called Open Sensors, which is basically focusing on both metrics and the tracing part. And finally in 2019, KubeCon, basically Open Tracing and Open Sensors got merged and OpenTelemetry got formed. In the following years, they have released the different SDKs for the tracing and all. Now let's take a moment to understand some of the key highlights of OpenTelemetry. So starting with the rapid adoptions. So this is the second fastest growing project under the CNCF hood, just after the Kubernetes. So you can see it has already gained the popularity over years. The next one is the vendor neutral. Because of its open source instrumentation and the interoperability, there is no vendor locking. So let's try to understand what do we mean by the vendor locking part first. So before OpenTelemetry came to the picture, right? So each of the observability vendor has their own way of collecting the data. There was no standardized way. So whenever you are trying to monitor your system, basically you have to do certain changes into your infrastructure or your application to so that the observability vendor can collect those data basically. Now over the years, right, whenever you are trying to again change to any other observability vendor, basically you have to go through that rigorous process again, which is painful for anyone. So because of OpenTelemetry, basically that locking part is broken because it's a standardized way of collecting the data, and then you just switch the vendor at any point of time. That is just a configuration change for you. Today you are sending to probably Dynatrace, tomorrow you can send it to Instana or Datadog or anyone. So there is no vendor locking for you, for your application. The next one is the industry standards. So in a very short span of time, OpenTelemetry has been adopted by the industry and the observability vendor in a very positive way. So everyone has embraced it into a very positive way, and now it has become the de facto of observability. So it now goes hand in hand with the observability of OpenTelemetry. And last but not the least, the comprehensive signal support. So it has a very good community support, and it has a lot of SDKs with different languages which you can leverage to collect the different signals of OpenTelemetry like metrics, traces and the logs. Now, what do you mean by the telemetry data? So telemetry is nothing but it's a heartbeat of observability. And the telemetry data is the data which is being emitted by your application or your system, which basically depicts the current state or the behavior. So basically there are three core pillars of observability: the traces, metrics and the logs. Now let's try to understand what do you mean by these three core pillars. So traces is nothing but it's the request or the transactions which is basically propagated through your different microservices in your distributed environment. Wherein matrix is nothing but it's a basically time series data points, which basically depicts the current state or performance of your application or your infrastructure. For example, the CPU utilization, or in case of application probably the error rate or the latency, those are the basically metrics. And logs, it's the same logs which is being generated by your application or your system. So OpenTelemetry is capable to collect those logs from the system and export it to the backend. So apart from these three core pillars, there is something I have mentioned over here as a baggage. Now let's take a moment to understand what we mean by that. So baggage is nothing but it's a contextual data. So for an example, if you want to send some of the contextual data along with your traces, let's say, for an example, along with your traces you want to send the transaction ID or a user ID or a region or any kind of non-sensitive informations, that for that cases you can leverage the baggage. So baggage is nothing but it's a contextual data, a key value pair, which helps you to propagate your contextual informations to all your downstream services. So that later point of time, it's easy for you to correlate those traces or logs later point of time. So apart from these four basic core signals, there are a couple of more under development signals is also there in the OpenTelemetry, which is called events and the profiles. So event is nothing but it's a basically a kind of a log only you can consider, but which is something noteworthy. For example, your application is using more than 80% of CPU, or your application has a certain latency for a particular API. So for those cases, probably you wanted to get alerted, right? Yeah, something is wrong. Probably someone has to take a proactive actions, a proactive measure for that. So that you can treat it as an event. Wherein profile basically gives you a much more detailed insight of your application. For example, like how much time a particular method or class is taking to execute, how much resources has been consumed by those classes. So basically it helps you to figure out any kind of bottleneck in your application, and it gives you a very in-depth details about your application basically. This diagram basically depicts the core components of OpenTelemetry. So starting with the API. So API is nothing but it's a fundamental interface or the plumbing which basically helps you or enables your application to interact with the observability framework. The next one is the SDK, which is the implementation part of those APIs, and it does the basically the heavy lifting part. And it is capable to do certain kind of processing like batching, filtering, or enrichment of data. Like you want to add certain kind of metadata along with your telemetry data, so you can do those in the as part of the SDK. And lastly, you have the exporter, which basically helps you to export those telemetry data to the observability backend. So it uses the OLTP protocol to export those data to the desired backend. So in this diagram, you can see like I have mentioned something as a collector as an optional part. So on the very next slide only, I will explain what is this collector all about. So collector, OpenTelemetry collector is nothing but it's a standalone service which basically helps you to receive, process, and export the telemetry data. So basically it sits in between your observability backend and your applications or the infrastructure, and it collects those data from your applications, which is, let's say, which is being auto-instrumented or manually instrumented using the APIs and the SDKs, and from your shared infrastructure or your infrastructure like Kubernetes or any kind of cloud providers. So it basically collects all those telemetry data from in a centralized place, and from there basically it can export those data to the observability backend. So in this way basically you keep putting a single point by which you can easily switch the observability backend. So let's say tomorrow you want to change the backend to any other backend. So basically you go ahead and do that changes into the collector in that part of the configuration. So basically it is able to do different kind of processings where you can define the pipeline which can do different kind of processings like again batching, filtering, or adding certain kind of metadata over there. And in fact it enables you with a multi-type of export, multi-dimension destination export. For example, a part of data you want to send it to one observability backend, and the other you want to send it to some other observability backend. So that part also you can do as part of that. And basically there are two flavors of the deployment model. One as a standalone, like this way, which sits in between those two parties. And the other one is like in the same service or the infrastructure where your application is basically running. And there you can start it as a daemon set or as a sidecar. Now let's try to understand what is this observability backend. So till now, whatever I have explained, right, this all about the collecting the data or certain amount of processing in those data. But those data, if you think closely, those all are independent data. Like you have a metrics which is being collected, which is traces which is being collected, or logs which is being collected separately. But they are not basically interlinked with each other. They don't know that how basically they connect with each other, right? So basically observability backend helps you over there. So it basically process those telemetry data, and it's build a 3D model out of it, where basically it helps you to figure out like how those data are being interlinked or correlated, so that it will be easy for you to find the probable root cause or the reason that why the latency is coming or why the service is not performing which is supposed to be. So let's try to understand like what we have over the diagram over here. So you have an application over here which is being auto instrumented, or some agent is instrumenting that, and you are exporting those telemetry data. So you have the data ingestion module in the backend. So the metrics ingestion, trace, and the logs ingestion. So once the data are getting ingested, it basically pushed into the Kafka. And on the right hand side, you have the data processing and the correlation part. So this is the part where basically the metrics, traces, and the logs are being correlated to each other, and the dynamic graph is being formed. If you are not able to understand what is the meaning of this correlation or this dynamic graph, I have a dedicated demo for that. Don't worry about that. Now, as we have all the raw telemetry data with us, right? So all the observability backend is capable to figure out whether any anomaly is happening in your system or not. And based on that, basically it can create different kind of issues and alert. And most of the matured observability system not only just help you with the finding of the events, it helps you with the finding of the probable root cause also with the AI-based remediations part. And finally, once you have the crisp data with you, right, basically you store those data to the different data storage. And finally, which gets exposed via the API, where basically on the UI, basically you visualize those data. Now let's go ahead and see the demo. Okay, why it is coming this way? Okay. For this demonstration purpose, I'm using the Instana, which currently I'm working in. This is one of the home page, and once you come over here in the infrastructure part, here basically it shows you whatever the infrastructure that you have, which basically collects all those matrices and all. So let's try to go ahead and do any of the host. This is the data that I was referring to as a metrics, basically, which is a time series data. Like each data point, you have a certain values over here. Like if you'll see, so this is basically all the matrices that which I was referring, like which you basically getting collected from the OpenTelemetry side. So like this way, how much system user or still user, those kind of informations basically are the metrics. Now let's go ahead and see the basically application. So let's go ahead. So basically this is one of the dummy applications which is called a robot shop applications, a shop which is trying to sell the robots basically. So here basically you see all the different KPIs and the metrics of it, like how many calls which is happening, how many error which is present over there, the different type of calls, the mean latency, 98th percentile, 99th percentiles, how much time basically it is taking, what are the different top services based on latency, calls, or the anonymous call. Now if I'm gonna come over here in the dependency section, so this is the part which I was explaining, like it try to build a dynamic graph out of your raw telemetry data. Now if we'll see over here, so these are all the services which is currently present. So this is a very small service, that's the reason you were seeing over here. And if there is any issue with any of those services, basically it will highlight you over here, like there is 1 or 2 issues which is present. And once you mouse over on any of the services, basically it tells you, okay, which is the service basically which is interacting with. So it has gained all the knowledge is based on your raw telemetry data, like how your application is performing. And you can have a very complicated system also, like this, where you have n number of services, but it would be able to figure out that also. Now if I'm gonna come to the services part, basically, yeah, these are the different data stacks which are being instrumented. This is the Nginx, Spring Boot, Redis, Node.js, MySQL, so all the different services which I just showed you over here, right? So these are all the services which is being interlinked. Now these are the log messages, error messages, those kind of information. So this is something interesting, this alerting part. So you know your application best. So you can basically set those kind of different kind of alerts over here. Let's say if the latency is more than this, probably you want it to be get alerted, because there are some of the critical service which always has to be up and running with meeting the SLOs and all. So basically you can define all kind of events and alert out of that basically. Now let's go ahead and analyze the calls. Basically, this is the part which is the tracing part which I was explaining. So let's go ahead and go to any of the services. Let's say I go over here. So I go ahead and click over there. Let's say there are 5 subcalls which is happening, like for a particular this request, it has landed into 5 different services. And if we'll come down over here, basically it's going to be giving you all the details about it. What is the service, from where it is coming. Currently it is mentioning that it's not monitored because probably it has come from a end user from the browser which is not being monitored. If that particular browser is or the application is being monitored, it will be coming something like this way. Okay. So here if we'll see, okay, it came from this particular browser, this operating system, this is the location, and these are some of the metadata. So if it is being monitored from the browser perspective or the application perspective, so that will be also getting monitored and interlinked at final place. So now let's come over here. So here basically you would be able to see what are the kind of queries which is being executed by this particular transactions, the different type of stack trace over here. For example, if I go to this particular request, so it gives me all the request which is being executed. Let me see if I can get some stack trace. Sorry, my bad. These are the different tags. So basically it gives you all of the informations, whatever is needed for you to find out like how the traces has been followed. Now let's quickly go to the log part over here. Let's try to analyze logs, and I'm really focusing on the error logs over here. So let's say if I come over here, this is the logs which is being captured from your application. And here basically you can see 2 parts. One is called as trace ID, one is called as in service ID. So trace ID is nothing but basically this is the trace or the request where this log has basically happened. So if I'm going to go to that particular trace over here, basically it would be showing me that what happened to this particular request. Like here I can see, okay, some error happened. So there are multiple error happened in this particular request. So you can see there are 5 subcalls, but out of that there were 3 erroneous calls, there are 3 logs. And if you wanna expand it, basically it will be showing you like, okay, where this error has happened. So if we'll come down over here, so this is the error which happened in this particular request. If we'll come over here, it would be giving, okay, what happened, the stack trace. In fact, it is capable to collect which part of the code basically where it's being executed. So somewhere it would be highlighted like this way. This is the line where it's being executing this particular code or this particular request. And in down below, basically it shows you what are the errors which has been happened for this particular request. Now, as I mentioned, like it is trying to do the correlations between. So you have the logs which is being collected separately, the request which is being collected separately, but later in the back end it get processed and it being correlated to each other so that it's easy for you to figure out or fix that particular issue. So that's the correlation part which I was mentioning about. Now let's try to go ahead and see the events part. So as I was mentioning, like that as we have all the raw data with us, right, it is capable to generate the event out of the box. So let's go ahead and probably, I don't know, let's go to any of the, let's say I go to this one where it is telling me that the calls are a bit slower in the discount service. So here if we will come, basically it is telling me, okay, this is the application, this is the service, and this is the metrics violations for which the events got triggered, because we have the metrics. So based on that only we have triggered the event. right? So this is the matrix that for which matrix it has triggered. So you can see the whole time series data for that. And this is something called a related event. So let me try to explain what do you mean by the related event. For example, there is a certain problem into your databases. It can be a driver problem or it can be a database problem. And that database is being shared across your multiple services, right? So now all suddenly, because of the database issue, suddenly all the services started getting impacted. So each of the services latency, let's say, got increased. Now all those individual services will start generating the events like, hey, my latency got increased now. So it is trying to correlate those kind of events, like which is probable because of the same reason which is happening. So it's trying to figure out like these are the same kind of event which happen because this is the reason of it. For example, in this particular case, I can see there are 9 related co-event, and here if we'll come like this is the probable root cause which is telling. So here it is telling me, okay, there is some issue which is happening on the discount service, like the error call rate is high, and if I'm going to click over here, so I can see what are the error is happened, and I can see that something wrong with the driver of the SQL services. Down below, it's going to be showing you all the analyzed calls, the logs, the associated event and everything. And if we'll come down below, basically it helps you with two parts. One is the recommended actions and one is the investigation part. So if you're going to click run investigations over here, right? So basically it will show you, okay, it's a bit slow the internet over here for me. Okay, so it will try to summarize like what is the reason that particular event got generated. So it has analyzed the logs or the request, whatever we have right over here, and it has telling me that okay, endpoint high anonymous call rate, and there is some connection timeout for some of the pool. So there is some issue with the some of one of the pool. So now you have the exact root cause with in front of you. What is the reason? Basically, all those services are having a latency or the call rate is higher, right? The error rate is higher. And now if you come down over here, the recommended actions part. So here it will, based on the along with the confidence level, it's going to be giving you that what are the actions that probably you can take. These are all the dev systems. So we have some dummy script and all those things are over here. For example, it can say, okay, you can restart the database. In this case, probably you definitely don't want to restart the database or not. That probably is something that you have to take a call, but it will give you different kind of options where basically you can run those scripts also. Like it can be a normal shell scripts or it can be a Ansible script. It can be basically anything. In fact, here you can generate the actions also. So based on the data, so this is the event details, whatever you have, you can put your insight also, you can generate. It will try to give you the summary of those particular events by analyzing those events and the data. Okay, what happened and what are the actions basically you can take, or what are the things that probably you can do to mitigate this particular issue. And like that way, basically you can generate the event also and create an action also. Okay, I think the name is already present, so let me put 1, 2, 3. So basically, once you create these particular actions over here, so it's going to be coming up over, okay, I think some privilege issue is coming over here. So basically, it would be coming over here. So from here, basically, you can, if something is like happening on a regular interval basis, because there are a lot of cases where basically, cases where you know if this kind of thing is happening, probably you go ahead and restart the pod or you go ahead and do something. So for those cases also, basically, you can create a kind of automated scripts. Like over here, like if this kind of event is happening, this is the script which go ahead and it would be automatically running without any manual intervention. So these are the kind of things which basically helps you with not with the event part, but also with the recommended actions or the corrective actions that probably you wanted to take. So yeah, that's pretty much which I would like to show over here. If you have any questions, I'd be happy to discuss. Okay, feel free to connect me over LinkedIn, and if you have any questions which bumped up later point of time, we can discuss over there also. Thank you so much for your time and patience.
Thank you.